The ventricular axis is one of the first things you normally look at when reading an ECG, and changes in the axis can indicate pathology. One of the most common ways to determine whether the ventricular axis is normal, that is between -30 degrees and 90 degrees, is to look at the QRS complexes in leads 1 and AVF. This diagram explores how changes in axis are reflected in 1 and AVF, and lets you quiz yourself on determining axis by looking at the QRSs in 1 and AVF. You can drag the ventricular axis arrow to see how the QRS complexes in 1 and AVF change. You can also tap the Generate Mystery Axis button to hide the axis vector. It's then up to you to deduce the approximate axis by looking at the QRSs and tapping somewhere inside the circle where you think the axis falls. You then get a bit of feedback on how close you were. Let's go over a few things. First, as you drag the vector around, the dashed lines follow along, indicating the vector projection onto leads 1 and AVF. If the projection is positive, that is, falls along the positive axis of lead 1, for example, then the QRS will be net positive in that lead. Here you can see that the QRS in lead 1 is net positive. What does net positive actually mean? Really, we're looking at the area under the curve for the QRS portion, with area above baseline counting as positive and area below baseline counting as negative. Usually this amounts to glancing at the QRS to see if it's more up than down, that is, if the R wave is taller than the S wave is deep. You would call the QRS net negative if the area under the QRS is net negative, and that would mean that the axis vector projects onto the negative axis of that lead. For example, like it is here for lead 1. The colored arcs show this idea. If we drag the axis vector into the lower left quadrant, let's pretend we don't know where the axis is and try to deduce it from the QRSs and the colored arcs. The QRS in AVF is net positive, and this means that the vector projects positively onto AVF. Therefore, the vector must fall somewhere in the lower half of the circle, and this is shown by the blue arc labeled as range in AVF. Likewise, the QRS in 1 is net positive, meaning the vector projects positively onto lead 1. The vector must fall in the left half of the circle, the patient's left, or the right side of the screen, and this is shown by the yellow arc. To satisfy both these conditions, the axis vector must fall somewhere in the overlap region, shown by the green arc labeled range of axis. The normal axis includes the range -30 to 90 degrees. One of the quickest ways you can say an axis is normal is to look at the QRSs in 1 and AVF. If both are net positive, then the axis is normal. Some people call this the 2 thumbs up sign, since the 2 R waves look like 2 thumbs pointing up.